So we all know now that we take any point P, coordinate x, 1 over x, the coordinate of P, and the coordinate of Q is x plus h, 1 over s plus h. Another way for you to get familiar with these coordinates, once you can get the coordinates of P, you can get the coordinate of Q. You already be told that coordinate of P is x plus 1 over x. And of course, it was from here that y is equal to 1 over x, which means this is the y coordinate, while this one is the s coordinate. You have been told that the coordinate of x, coordinate of P is x and y and 1 over x. So therefore, your y, that means the graph itself, is derived from this coordinate P. So this point P, which says that your y is equal to 1 over x, which is actually saying that this one is y and y axis and this one is x axis. So if you know the coordinates of a point, then the other point of reference is easier to synthesize. How? Q, because we have known that the difference is that there is a h added to a point x. So in the axis of the x-axis, as related or reference to Q, is simply x plus h. That is what we are getting here. So this actually is the x-axis of point Q. Then the y-axis, simply from here, you will also get it, is equal to 1 all over. Instead of having 1 over s, you have 1 over s plus h, which is the y-axis of point Q. So if this is clear to us, it's going to be very easy when you will be doing your own assignment or classwork. So we cannot say gradient from our graph. If you are familiar to what we have been doing, you discover that it will be very easy for us. Our vertical is simply P arrow. So gradient is equals to P arrow all over what? Q arrow. So what is our P arrow? It means, I've told you severally that you have y2 minus y1. So that is just the same principle. If you discover this is your y2 and this is your y1. So if you can get that into your head, then you have made a basic acquaintance with the procedure. Then we can now say that substituting into this P arrow, we have 1 over x plus h, which is the y2 that we are talking about. Then minus what? Your y1, which is this one, which is 1 over x. So if you have gotten this principle right, it's very clear. Then your Q arrow, if you go to the graph, is just h. So what you have there now is gradient is equal to 1 all over x plus h minus 1 over x all over h. Now, if you look at it, because we are trying to simplify this gradient function to the barest minimum, so that it doesn't look as if it is a difficult task. So if you look at this is just simply your LCM. If you look at this, a factor, just as you add or subtract 1 over 4 minus 1 over 2. So that's what we are doing, or 1 over 6 minus 1 over 8. That's what you are seeing here. But the only difference is that this one is in alphabet while that one is a number. So you treat this one as what we call two factors, or two factors. This one treated as upper factor and this one as a lower factor. So this upper factor is a fraction of its own, while this lower factor is also a fraction of its own, because what you're having here is simply h over 1. That's what you have. So you now see that you have upper factor, you have lower factor. So let's look at these two factors. We have the upper factor and the lower factor now. These are two different fractions. Just like you have 1 over 2 divided by 1 over 4. That's what you have. So, but let's treat the upper one. We are treating the upper one, which is 1 all over x plus h minus 1 over x. Use your LCM. It's simply x into x plus h. This will cancel this, which means you have x times 1 become x. Put your minus sign there. This will cancel this, which means you have this. So you are going to have x plus h. So you have these answers coming up, because this x will go with this. What you have in bracket is x plus h. So you have x into bracket x plus h all over x into x plus h. So what you now have there is you have been able to get the upper one, and the lower one is simple because it's all over h. So we can also say that if you want to bring this together, we can say that x minus bracket x minus 1, x bracket x plus h all over what? X into x plus h. If you invert it, it's going to be 1 all over h. So having done that, you will discover that if you open your bracket, you are going to get something that looks like this. It's going to be, you are going to have x minus x minus what? H. That's what you are going to have. And if you look at what you have down, it's going to give you what? You're going to have a multiplication, because if you expand this, you're going to have x squared plus sh into what? Into h, because of this h. I don't want us to. So you are going to have this one will die with this one. So you are going to have minus h in all divided by s squared h, because we are multiplying this one, plus sh all squared. So that's what we are going to. Now what we have said, that gradient now, the gradient function of the limiting function is equal to minus h all over h into s squared plus sh. Now, what we need to do is to see how we can cancel out the common factor. This one is common, this one is common. So which means you have minus 1 all over what? X squared plus x-ish. We are now saying that if h tends to 0, sh is equals to 0. Therefore, your gradient function is equal to minus 1 all over s squared minus 1 all over s squared, because these are tend to what? 0. So the gradient function, the gradient at all points on the curve y equals to 1 over x is what? It's negative. So you'll be given a classwork, you get to me at my email onaiwustar@gmail.com. Find the gradient function by the limiting process. 1, y equals to 2s squared. 2, y equals to 2s squared plus 3. 3, y equals to 2s squared minus 5. 4, y equals to s squared plus x minus 1. Thank you. As I get your feedback, then we can communicate as we see ourselves in Unit 5. Bye.